Hess's law states that the total enthalpy change for a chemical reaction is the same regardless of the path taken, provided the initial and final conditions remain constant. This means the energy change for the direct route equals the sum of the indirect steps. To visualize this, we use an enthalpy cycle. By using the standard heats of formation for both reactants and products, we can create a closed loop that allows us to calculate the unknown enthalpy of a specific reaction. The standard heat of formation is the energy change when 1 mole of a substance is formed from its constituent elements in their standard states. We use these values as our building blocks for complex calculations. Because energy is conserved, the sum of enthalpies around any closed loop is 0. If you must follow a path against the direction of a formation arrow, simply flip the sign of that enthalpy value to keep your calculation accurate. Let's apply this to the combustion of methane. We start by identifying the standard enthalpy of formation for each reactant and product involved in the chemical equation. We construct our cycle by placing the constituent elements at the bottom. The arrows represent the formation of methane on the left and the formation of carbon dioxide and water on the right. First, we sum the enthalpies of formation for the reactants. Note that the enthalpy of formation for pure elements like oxygen is always 0, so our reactant total is simply negative 75 kilojoules per mole. Next, we calculate the sum for the products. We must multiply the formation value of water by 2 because there are 2 moles produced. This gives us a total product enthalpy of negative 966 kilojoules. To find the reaction enthalpy, we subtract the reactant sum from the product sum. Subtracting negative 75 from negative 966 results in a final reaction enthalpy of negative 891 kilojoules per mole. On an energy level diagram, we see the reactants sit higher than the products. The downward arrow indicates that energy is released into the surroundings, confirming this is an exothermic process. In summary, always start with a balanced equation, map your formation cycle, substitute your known values, and use the product minus reactant formula to solve for the enthalpy change. Hess's law is a powerful tool in thermodynamics, allowing scientists to predict energy changes for reactions that are too dangerous or slow to measure in a lab. Thank you for watching. Generated by Vision Solve AI.